Hello, this is Deep Learning Classics and Trends. It's a reading group. We've been running for 5 years now. And I like doing things different every now and then, just to throw in something creative. So this time I thought I was reading so many Minecraft papers and projects on Twitter. And I was just amazed that at that very moment, a lot of Minecraft energy was bursting, and I'm curious of why. So I thought like different teams should gather together and do this jam session more and also easy, and because DLCT is happening every week, and I sort of know everyone from past work relationship and just social events. So I just put everyone together in a thread and this happened. So yay. So great. So this is kind of like a panel, but we go very casual. That's the vibe of DLCT. So feel free to keep it casual. Usually when it's a talk, people also would ask questions during. So I don't know about this one. I think we can also allow questions during. What do you guys think?
Sounds good to me.
Okay.
Yeah,
cool.
sounds great. Yeah, of course.
Cool. Okay, to get started, I think maybe each of you can give a brief intro of yourself, your team, the Minecraft project team, and maybe one sentence about why do you think the Minecraft is a good problem to work on. We can start with on my screen, Sebastian.
Sure. Should I share some slides, or we do without slides, or I don't know? Like,
In the slides, yeah. I think slides would be nice.
Okay. Let's see if the sharing.
We lost Sebastian.
I think we lost him.
He muted himself and turned his camera off, but provided no slides.
Right? Can you still see me?
Now we can. You came
Yeah.
back, and we can hear you, but no slides.
No slides. Well, let's see if this works on my phone. Maybe I have to do without slides. Then I'll just
know how to share slides on your phone.
On a phone? I'm very impressed.
I know.
Yeah. Well, maybe it doesn't work. Then I'll just wait. I'll try one more thing, and then I'll because I don't have my laptop. Okay, then I'll just talk a little bit about this project.
Oh, no, it's working.
Wow, nice. Your phone.
I see your phone.
Wow.
You have 4 WhatsApp
Okay.
messages you haven't checked yet.
This is amazing.
Don't look too close to what messages I get. I try to get to the quick. Do you see the Minecraft thing?
I
You see
this
the
is the
slideshow?
first time that I saw
it to show up
looks
on your
perfect
phone.
from phone.
You see the slideshow?
It's perfect.
Yes.
Yeah.
Yes, looks
Okay,
amazing.
excellent.
Yeah.
Yeah, okay, perfect. Yeah, so we started a few years ago to organize this Minecraft open-endedness challenge, basically, and the team is Georgie, Rasmus, Elias, Claire, a few people from ITU University. And our motivation kind of was that, you see all this kind of great diversity in nature, and we want to kind of create algorithms that can invent similar things in an open-ended fashion. This challenge that also Jeff is working on, and Ken and Joel. So we want to create algorithms that can, in an open-ended way, generate interesting artifacts and never stop inventing, similarly to what basically evolution did in nature. And then we were looking at different kind of frameworks, artificial life frameworks, and we thought they're all interesting. They allow us to answer like interesting questions, but there's no real framework that allows us to study really this question of open-endedness in a way. Basically, if you let it run, you would be surprised kind of what things would come out of the system, what things would it invent that you didn't even think about. And that's why we thought Minecraft is kind of the perfect platform from this, because people have been able to build all kinds of things in Minecraft. Computers, simulating Atari games, neural networks, robots, basically anything you can imagine you can build in Minecraft. And with these redstone components, you can actually build also circuits that do computations. And you can build fully functioning work processes. Basically, anything you can imagine, you can build in this. So can we make an algorithm that was kind of the goal that could create similar things automatically, that could invent, a computer or all kinds of other things in this game. And I think in contrast to some other of these competitions, we're not focused on so much on the agent. We have more like that we allow the API allows directly to spawn blocks and delete blocks and read blocks in the environment. So it's more about what kind of structures could be made, but not so much about from an NPC perspective, more from we allow the direct manipulation of basically blocks in the environment and provide a very kind of simple API, but then nevertheless allows you to run things like optimization, evolution. And then we did this competition basically where we wanted to see what kind of
Sebastian, you're muted for whatever reason.
Yeah, we lost your audio. We can still see the beautiful slides and videos.
Maybe when the video starts playing.
Oh, yeah.
Muted or something.
That's a pretty good idea. That's a good hypothesis.
Hmm.
Go on to your next slide and we'll see if you come back, Sebastian.
Can you hear us, Sebastian?
Might not be able to hear us.
Huh, wonder. Oh, because this is also a video.
Mm-hmm.
Let's just comment through his slides. Like
Yeah, so Rosette.
So it looks like this may be one of the winners, I'm guessing. Let's see what they come up with in the competition.
So I suppose this is like procedural generation inside a procedurally generated world.
Okay.
It's really cool. Yeah.
Procedural as in one block after another.
Yeah, and also like it's not repeating. Like in the previous one, the building has different rooms in every block. I guess it's like algorithmically generated.
This is a fun experience, like us commentating on
Yeah.
slideshow, and then I'm back. Did you guys see everything?
we couldn't hear you the whole time, Sebastian. I'm sorry.
You couldn't hear me?
No, you were muted, but we got the gist. There's some nice generation.
Oh no, that's really. Oh, can you hear me now?
Yes.
That's
So when
weird.
you're playing the video, I think you're automatically muted.
Oh, that's when it muted. Okay. Well, yeah, just check out the site EvoCraft.live, basically, where it explains a lot about the framework and things.
Yeah. So what did the winners the winners' creations tell you through this competition?
Yeah. So last year we had this. The winner did this. Niklas Gutenberg. He had this like evolution of three of circuits in Minecraft. So like in an open-ended way, it would invent novel circuits using these redstone components. And this year the winner, they used like a clip, basically neural network, to invent all kinds of novel like images and create kind of like family trees of different concepts. So you have the concept of a tree, and then you have the concept of a table and the concept of a chair, and making all these structures in Minecraft. Yeah, so there's a lot of possibilities. Like, it's nice, I think, this competition that allows people to do very, very different things. It's not focused on like one particular thing, but just things that create things in an open-ended manner, and there are a lot of different approaches people take in that direction.
Yeah, that's cool. Okay, then we will move on to Jeff. You're next on my screen. And I know we all know Sebastian for a long time. So were you inspired by the competition? Was there any linkage of how you decided to work on Minecraft?
I love Sebastian's work, but I cannot say that Sebastian's work inspired our particular work. But I think it's probably like common cause, which is the idea that, as Sebastian mentioned, many of us, and he listed some names, Joel, Ken, myself, Sebastian, others, have been fascinated by this question of like, how can you recreate the open-ended explosion of complexity that you see in the natural world, you know, where a simple process produces jaguars, hawks, and human brains, three-toed sloths, dolphins, you name it. And one of the things you quickly kind of run into when you work on open-endedness is this problem that if you're in a very simple restricted domain, then it's hard to really push the algorithms to their limits and put them to the test of like, what would you do if you were in a very rich open-ended environment? And so it's kind of like almost natural if you think like, what's one of the most open-ended environments out there? Minecraft is it. You know, it's a sandbox game. It doesn't have a clear objective. People have done, I mean, Sebastian just showed all these different things. There's just like an infinite number of possible things that you can do in there. Another thing that really motivated us, and when I say us, I'm talking about the team at OpenAI that put together the VPT, which is video pre-training paper and project. If people aren't familiar with that, then you can kind of quickly Google it. You'll see the list of the wonderful team members. But one of the things that we were thinking there is, you know, I think one of the clear trends in the last few years of machine learning is that, you know, AI will see farther and move faster if it stands on the shoulders of giant human data sets, which is kind of a play on the Isaac Newton quote, right? And so we can dramatically catalyze and speed up and improve the ability of AI to do anything if we pre-train first on human data. And so Minecraft has this double win for us. One, it's a huge open-ended environment to play in. And two, there's a tremendous amount of human data out there. And so we were motivated to try to unlock the amount of data that you see on YouTube and directly be able to learn by watching YouTube videos. And I know that you and Jim have also done a fantastic job of thinking hard about the potential that's there for pre-training off of human data, and their MineDojo project, which I'm sure they're going to tell you about, is a wonderful example of that as well, which happened in parallel. So obviously we were thinking along very similar lines independently. So those are the reasons we were really interested in Minecraft. But I should also point out that I don't think Minecraft is an end in and of itself. It had those two properties. And there are other things that have those properties, and eventually we probably want to work on other domains as well. But I do think Minecraft is a fantastic test bed because it's got the human data, it's open-ended. It's also quite hard, you know, like especially if you do what we did, which is play with the keyboard and the mouse. You're really starting to take AI out of these like simplified environments where we make everything really easy. And we have macros where they can do complex things with the push of a button, and just say like, you know, you have to deal with very long action sequences, tens, hundreds of thousands of actions. You've got to deal with extended time scales, huge action spaces, 3D worlds, point of view pixels. You know, we're starting to kind of see AI transition from toy environments to human environments. And so, you know, humans have spent a ridiculous amount of time in Minecraft because it's complex and interesting and open-ended. And now we can start to see AI do that as well.
Cool. So Jim, one of you can jump in.
I guess like Jim have some slides to present. Maybe like he can go first.
Yeah.
Okay, yeah, sounds good. First of all, thank you so much, Sebastian and Jeff, for like introducing the Minecraft. So yeah, I don't need to reintroduce it again, and all of the motivations you guys have covered. I vigorously agree on all accounts. That's why I'm working on this in the first place. Like totally great points you guys have raised. And let me share slides. I have some just cool pictures and videos. So everyone relax and enjoy the show. Yeah, let me share screen. Okay, so All right, can everyone see my screen? See the PowerPoint?
Yes.
Awesome. Yeah, and also thanks Roseanne and ML Collective for hosting this great event. My name is Jim, and on behalf of the NVIDIA team, I'm very excited to share with you initiative called MineDojo built on Minecraft. So Jeff has already covered some of these main points, and I'll just do a quick summary. The grand goal that we want to pursue is to build a generally capable agent. But what does that mean? We argue that a generalist agent should have 3 properties. First, instead of maximizing some scores, let's say in entire games, the agent should be able to discover and pursue very complex and open-ended objectives. And second, a generalist agent, as its name implies, must be able to do a large number of tasks. Or even better, can we prompt it with arbitrary natural language command, just like GPT-3? And third, the agent should understand how the world works through massive pre-trained knowledge. Also another great point Jeff covered, instead of training from scratch every time. Towards this end, we introduced MineDojo, a framework built on Minecraft for AI research. MineDojo implements a recipe of 3 ingredients towards generalist agent. So the first is open-ended environment. Next, internet scale knowledge base, which VBT also touched on. And finally, can we learn a foundation model for embodied agents using the simulator and a massive data set? So let's zoom into the first one. MineDojo features a massive benchmarking suite of more than 3,000 tasks. So this is among the largest open source agent benchmark created, to our knowledge. It is enabled by a versatile simulator that unlocks the full potential of Minecraft. So for example, it supports multimodal observation and action space. It can also be customized at every detail to make a wide variety of environments. And given the simulator, we introduce around 1,500 programmatic tasks, which are tasks that have ground truth success conditions. And examples are harvesting different resources, learn to use a tree of tools, and combat various monsters. But Minecraft is more than that. So we also introduce 1,500 creative tasks that are freeform and open-ended. For example, let's say we want the agent to build a house, but it's really hard to define what makes a house a house. So these tasks don't have a simple check, and human judgment or learned scoring methods should be used. Moving to the second ingredient, MineDojo features an internet knowledge base of 3 parts. The first one is YouTube. So we find that Minecraft is among the most streamed games on YouTube, and gamers love to narrate what they're doing. So we collected more than 700,000 videos with 2 billion words in the transcript. And this provides very rich learning material of human strategies and also creativity. Second, players have compiled a large Minecraft-specific Wikipedia that explains every entity and mechanism that you need to know in the game. We scraped 7,000 wiki pages with interleaving multimodal data. So for example, this is a gallery of all the monsters, all explained in the wiki, and the crafting recipes, everything you need to know. Finally, the Minecraft subreddit is a very active forum. Players have showcased their creations and also asked questions for help. Here are some examples of how people essentially use this Reddit as a Stack Overflow for Minecraft. And we can see that the top voted answers are actually pretty good. Cool. So now, given the massive task suite and also the internet data, we have the essential components to train foundation models. And in MineDojo, we propose a new algorithm that takes a baby step towards this ideal of a generalist agent. So the idea is quite simple. For our YouTube database, we have time-aligned video clips and transcripts in natural language. So we can train a contrastive video text model called MineClip in the same spirit as the OpenAI clip. Intuitively, the model learns to associate the video and the text that describes the content. And then we repurpose this MineClip model to be a language-conditioned learned reward function for our agent. So here's our agent interacting with the simulator. Let's say the task is share sheep to obtain wool. As the agent explores, it generates a video snippet, which can be encoded and fed to the MineClip model. So intuitively, the higher the association score, the more the agent's behavior aligns with the language description. So that becomes an effective reward function to any reinforcement learning algorithm that you like. So here's our learned agent behavior on various tasks. It is a multitask agent that we trained. But still, I want to point out that what we can do is pretty far from the awesome things that human players have demonstrated, such as recreating the entire Hogwarts, or even simulating a CPU circuit that Sebastian already covered. So here's a call to action for the community. If humans can do these mind-blowing tasks, then why not our AI? So that concludes a whirlwind tour of MineDojo. A lot more contents are available on our website, minedojo.org. So yeah, please visit the website and let us know what you think. Our simulator suite, database, and also Minecraft models are open source. And another big shout out to Jeff's team. You guys have open sourced OpenAI VPT checkpoints and human contractor data as well. So all of these are complementary and will be very useful for the community. So please check out all of these resources. And this project is a big teamwork at NVIDIA. Our co-advisor, Professor Yuka Zhu, is also here to answer any questions you have. So thank you all so much. Yeah, and back to Roseanne.
Cool. So let me zoom into that pre-training part, because I think that's the part that MineDojo and VPT sort of shares. So you both use video. And in MineDojo's case, you have paired, do you call that caption or some text? What about in your case, Jeff, in the VPT's case?
Yeah, so we, I love so much of the vision that's in the MineDojo project. And we had thought about a lot of taking advantage of things like the captions, which we played with and put in our appendix. We didn't even think about and get to the Reddit stuff. So all that's really cool. So we don't have those pieces. What we do have is something a little bit different. The MineDojo team, they did something where they took videos, but they even mentioned in their paper, we don't have the action labels for the video. So they did like a contrastive kind of learning where you're learning representations from the video. You're harnessing these videos to kind of learn how to see and know what's going on in the world, but you don't necessarily start knowing how to act with that kind of contrastive learning. We were interested in seeing whether or not we could actually get all the way to an agent that kind of learns how to act via pre-training, which is to say, knows in this situation, I should take this action. And to do that, we needed the actions that the humans were taking. And so we had this idea that we would basically try to solve, the task of, if I can watch a video on YouTube, I can probably figure out what action must be taken at each point in time. And so the way that we do this is we take just a small amount of, relatively small amount of contractor data. We used 2,000 hours. In the end, it turned out we probably only needed like 100 to 200 hours. And we pay contractors to play Minecraft, and we're recording their actions as they're playing the game. And so then we train a deep neural net to say, if I can look at the past and the future, what action must have been taken in the middle? And that's actually not that hard of a task, right? Like if you see a hand move, then you probably hit the karate chop button. Or if you see a block get placed, you must have hit the place block item, et cetera, et cetera. It's a relatively simple task. And this is a general principle that works across almost any game or situation, but the physics of the world tend to be consistent and not that complicated, especially in video games. And so it's not that hard to know, oh, you hit jump, you hit forward, you hit backwards, et cetera. Once you learn that model that knows how to look at past and future and infer the action that must have been taken, you can take that model and you can run it on all of the videos on YouTube and label them with the actions that must have been taken. And now you have a gigantic database of videos and actions, mappings, and then you can just train a model via behavioral cloning, imitation learning to go from state to action, and just pre-train at scale. So we ended up pre-training on 70,000 hours, which is about 8 years of videos of people playing Minecraft, where now we have the actions and we just do imitation learning, behavioral cloning at scale. And then you're basically kind of like in the GPT style of learning. That's why we named it VPT as a nod to GPT. Where VPT stands for video pre-training, where the model does all the things that GPT does. It kind of comes out of the gate with a lot of zero-shot capabilities, where it can do pretty impressive things. And then with a little bit of fine tuning, you can get it to then go off and do all sorts of very complicated things. And we showed in the paper that you can even get it to mine diamond tools, which takes humans over 20 minutes. And I forget exactly how many, but tens of thousands of actions, I think, in a row, which is just unprecedented if you go back to a couple of years ago in RL, to think that agents could be not only learning that, but in this case, kind of learning it in an unsupervised way, basically for free from the internet, which is pretty cool. And so the idea is, going beyond Minecraft is that you could imagine going to almost any domain for which there's lots of video out there on the internet, and you train a model that infers the actions, then you label those videos, and then you can pre-train a model to basically, as I said earlier, stand on the shoulders of giant human data sets.
Yeah, I just want to add a bit like to Jeff's point. So one thing that we really like about Minecraft is first, like this is like a game designed for human, right? So and human use mouse and keyboard interface to play this game, and this keyboard and mouse interface is pretty universal. Like a human does use this to play all kinds of games, but even beyond games, they use this to like Photoshop Instagram pictures or like a design 3D ships in Unity and all those kind of things. So you can imagine like the similar principle can be applied to those kind of other domains and using the same interface and like for building applications, real world applications, right? So really kind of the richness and also the kind of the universal user interface offered by Minecraft is really kind of what appeals us and to build a benchmark off the top of it. So actually, for context, like when we first started like this kind of MineDojo projects with Jim, so we can be looking at what existing benchmark in particular, like say continual learning, lifelong learning have to offer, and we found that there's a lot of benchmark developed in the community as like pioneer work, but when they say like a continual learning is 20, 50 tasks, and then your agent learns like for 2 hours, right? And then you get the end of the list of tasks. But really, kind of the openness and the kind of infinite possibilities what makes human play this game for years. So that's why we thought that this could be a really deep platform to enable kind of a much large scale study of like kind of how to deploy embodied agents to learn throughout the entire lifespan of an agent. Like, so now we're talking maybe like a month or even years of learning, right? So these are the kind of the possibilities offered by the open-endedness of the platform.
Yeah, I wanted to jump in on a few points there, which I think is really interesting. One is we also were really motivated by the fact that the interface in Minecraft is particularly interesting, not just because you're using a mouse and a keyboard and you're in a 3D space, which is, a lot of what humans do, but also because it has these kind of games within a game. You've got to do crafting, which opens up basically something that looks a lot like a little computer application. And you have to drag and drop these little icons and do precise sequences. And so one of our motivating use cases was computer using agents that eventually learn to do things like Yuki was just saying, like Photoshop and using Microsoft Word or Google Docs or whatever. And so being able to precisely do drag and drop sequences with icons was like a really nice added challenge within Minecraft because it requires a lot of precision and it's kind of like a different modality within the game. Another thing I think was really cool is that you can imagine that you don't necessarily need to follow exactly the playbook we did, where you train contractors in one domain and you have what we call this inverse dynamics model. That's the thing that labels the actions given past and future. You don't have to have that necessarily be domain specific. You could imagine trying to learn a very generic IDM that works across all domains, or at least all computer using domains, for example, where you have the same input output space, which is basically mouse pixels to mouse and keyboard. And in fact, just yesterday, the team at OpenAI that worked on VPT, somebody found that somebody had taken our exact pre-trained Minecraft IDM and run it on this game Fallout, which I'm not familiar with, but it's like totally visually different. It's like a 3D game, but it doesn't look at all like Minecraft. And apparently it's working relatively well, which I wouldn't have expected. And I'm surprised. But imagine if you trained on like 10, 20, 30 games or domains or computer using applications, and then you can generalize to the next and the next and the next, and kind of like just add more and more pre-training, and you get this one generic IDM that can recognize what action must have been taken in a whole lot of different domains. Then you're really off to the races in terms of pre-training an agent on all the different things that people do on computers. The final thing I wanted to mention,
also add something.
Sorry, go ahead, Sven. I'll just really quickly mention on continual learning. We actually do have evidence that in Minecraft, continual learning is a problem. The previous paper we put out of OpenAI, out of my team, was on curriculum learning in Minecraft. And the agents, if you try to train them with a curriculum of like based on learning progress, whatever, they'll continuously learn, but they're learning new skills at the expense of forgetting old skills. And we see this fall off in skills from things that they already were really good at because they're learning the next thing. And if we didn't properly do curriculum learning and continual learning techniques to abate that, then that would show up. And that's because Minecraft is complex and rich enough, and you can focus on one totally different aspect of the game and forget this other one. So that is another really nice element of challenging AI problems that shows up in this game that doesn't show up in a lot of simpler RL games. So I'm glad you mentioned that, Yuki. Sorry, Sebastian, go ahead.
Yeah, I think following up on this, I think what also makes it really nice is that the game offers so many possibilities that you can do like RL tasks, like learning from human data, but you can actually now there's some siren in the background. But you can actually also focus on what I think is really great, that you have the survival mode where you have to do this crafting, but you can actually and also have this creative mode where you build all kinds of crazy creations. So there is no, basically you have to make an algorithm that can create things in an open-ended manner. I mean, you can learn to kind of replicate basically what humans have been doing in Minecraft, but and you can do this on a very low level like mouse and keyboard. But then you can then go further and you can try to build on this. Now we have an algorithm that can do the basic things that humans can do in the game, and they can mine diamonds and can craft. And then I think the next step would be that you can they actually create similar things to what humans have been created in the game. And I think it's really interesting to think about what would it take for an AI to invent a computer in Minecraft? Like what kind of selective pressure would it make for an AI to invent a computer in Minecraft, or invent a neural network in Minecraft, or all the other things that humans have been inventing? Can we kind of bias these systems to inventing these things because they're somehow useful for some in-game behavior? And what kind of open-ended algorithm would ever discover those things? I think that's really interesting, and it Minecraft allows you to simulate things from the lowest level to basically the highest level of kind of human creativity. You just kind of Lego-like building blocks that where you can basically do anything with. That's also what I think is really really exciting about it.
Yeah, I want to follow up on a slightly different point that Jeff, Yuka, and Sebastian brought up, is on the data side. So Jeff said we're standing on the shoulder of giants. I want to provide a statistic in case people don't know. Like for Minecraft, there are 140 million active players. So just to put this number in perspective, this number is bigger than the entire population of Mexico and twice bigger than the population of UK. So crazy. It is like this many, like massive number of humans playing this game, generating all the data, all of the knowledge. So I feel that, back to Sebastian's point, what does it take to build a computer in Minecraft? I feel that maybe we can get started from data-driven creativity. There are already like so many open-ended objectives and things, awesome, even like crazy things that humans have done, demonstrated in either YouTube or explained on Reddit step-by-step using language, right? So can we like first mimic some of the diversity and creativity that human players already do? And then once we have some kind of foundation model for creativity, then we build upon it using like evolutionary algorithms to bring it to an even higher level. So that's like very analogous to what AlphaGo first did. Like they first kind of bootstrap from human play, and then self-play gets it to like superhuman regime. So I feel that on the creative side and also on the policy learning side, I think both can benefit a lot from the data. And the other point is for all of these like YouTube or Reddit or Wiki data sets, language is a central component. And I feel that these days NLP folks are having a great time. Like agent learning is falling a bit behind from what NLP people have achieved. Like the GPT-3, all of those already open-ended large language models. Like GPT-3 is open-ended. You can explain a task to it in any natural language, it will be able to do it. But we do not have any agent that can just tell it arbitrary things and it will be able to do it. We are so far from that ideal. So I think maybe it's time to leverage some of those technologies created in the NLP community and then apply them to Minecraft. And we have the data. We have all the language, people explaining, narrating what they're doing in YouTube. People also like kind of telling about all of the knowledge and table of contents on Wiki. And all of these data can be utilized combined with natural language. Yeah.
Maybe one remaining thing is also the other thing about also study is also like collaboration of humans, like because you have all these also the data sets that you guys created. You have all these data sets also of like people building things, for example, together, and then that requires a lot of collaboration. And if you see those videos like of hundreds of people creating Minecraft structures together, it's amazing how like somehow they work like this collective system, creating amazing things. So I think that's also a rich source of how do humans collaborate in this game, and can we make some algorithms that do similar things, and even maybe collaborate, you know, not just the eyes separated, but even collaborate maybe together with humans in some way in the future.
I completely agree. And also language will provide a very good channel for the humans to communicate with the agent. And we have models like GPT-3 that understands language. So, you know, plugging it into some kind of Minecraft agent will even facilitate this kind of human and AI collaboration, because natural language is just such a, you know, comfortable interface for us.
Yeah, a couple of things. One of them is that one of my favorite parts of the MineDojo paper is the emphasis and the vision on natural language conditioned agents. I'm a huge believer that this is the future of agents in general and RL agents in particular. And I love the idea of trying to harness the data that's out there, like in captions, to produce that. So in our appendix, we played with that idea a little bit, but we didn't get it to work nearly as well as you guys did. And I just think that that is going to be very, very powerful going forward, because as you said with GPT, you want to just be able to tell the agent what to do, and then it can go do it. And that also dramatically decreases the exploration challenge of the task. Most of the time, you know, when we give an RL agent a task, you know, it's basically the equivalent of putting it in a giant cluttered room and say, go. And what we really want it to do is like, go get all the blue things, but we don't tell it that. And it's just flailing around randomly trying to figure out what the heck we want. Like, just imagine, even a human would do terrible at that task. But if you could just tell the agent, go get all the blue things, then it's just a matter of mastering the physical skills of picking up the blue things, which usually is very, very, very easy for humans, and ultimately will be for agents as well when they come to the task with skills from other domains. So I think this natural language conditioning is just very, very, very essential for going forward. And so I love that you guys were focusing on that. And I love that you're also focusing on how we can get it via pre-training off internet scale data, which is really fantastic. I'm very, very bullish on that as a future direction. Another thing I wanted to mention, which is also related to the idea of overcoming kind of the exploration challenges with tasks, is, you know, a few years ago, I put out this idea of AI generating algorithms. So we were going to try to bootstrap up from very simple conditions all the way to superhuman AI. And, you know, the inevitable question I got from everybody, but also that I had myself, is kind of like, how are we going to do this without a planet-sized computer, as Josh Tenenbaum put it when I put this idea to him. And that was a real challenge. The question is like, how are you going to shave many, many, many orders of magnitude off of what happened on Earth in order to have this happen within the computational resources that we're going to have as AI researchers? And, you know, one of the big challenges here is kind of bootstrapping, getting into the regime where you can start to learn new tasks, where you have to learn all these initial skills, including like what language means and like how to move about the world, et cetera. And that's where I think this standing on the shoulders of giant human data sets thing comes in. And I think the VPT paper really shows this well, the MineDojo paper as well, where basically we show that if you pre-train on all of this internet scale data, and then you challenge the agent to go get diamond tools, it can do it. Whereas if you don't have that pre-training, it basically will never happen. Now, never, you know, we should put it in quotes. I mean, with infinite amounts of compute, eventually you'll figure this out. And there are projects like Dota that did impressive things without any pre-training. But as Jim just mentioned, you know, a lot of works like AlphaGo and StarCraft, they seeded learning with pre-training. And then from there, you create the next wave of learning. And I think that's what's really exciting in terms of open-endedness, that probably like we can leapfrog ahead from like the first couple billion years of evolution right into a regime where we have pretty capable agents that then can kick off an open-ended process. And we can do that by pre-training on human data. And so I think the future is very exciting for open-endedness research, because it seems now possible that you could use pre-trained models, like video pre-trained models, language pre-trained models, to kick off open-ended processes, maybe like within like the next couple of years. Whereas before pre-training, it seemed like we were ahead like a much bigger mountain to climb before we'd be able to see truly open-ended processes.
Maybe just a question here. When we talk about pre-training, of course, we're thinking of massive data. Does it have to be self-supervised, or do you think a little bit of human label data in the beginning would get us a long way, the way that VPT did it?
Yeah, I was just going to say that VPT is kind of an example where you can use a little bit of human data as like a great catalyst, right? A great multiplier that allows you to unlock huge amounts of unsupervised data. So I don't think there's any reason why you shouldn't mix the two. if as long as you can do a little bit of the expensive stuff and a lot of the unexpensive stuff, I think that it's a very powerful formula.
I mean, I'm also like I think pre-training will definitely get us a big way there, and it's really like impressive. I'm wondering sometimes if there are any like drawbacks we could think that pre-training might get us stuck somewhere from which it is hard to get out, because we are like I mean, to be a little bit, not only positive, like could it be that we have these large foundation models, like we pre-train on things that I'm also a big fan of, but could they also result as that we're getting somehow stuck somewhere from which it is hard to learn more, well, as if we would have started from from scratch without any human data, by letting the algorithm discover its everything itself, would we somehow not have went to this cul-de-sac? I'm not sure if that will actually happen, but it's something that I'm sometimes thinking about, because now everybody's we're doing a lot of these using a lot of these pre-trained models in a lot of different areas. So is there any kind of, I don't know if you guys also thought about those drawbacks that you could imagine, or do you think it's always useful to have these pre-trained models and then kick off this kind of more open-ended learning?
So I think that in the AIGA paper, I talk about how exciting it will be once we figure out how to make these open-ended AI generating algorithms. We could run them multiple times and see vastly different types of intelligence show up, almost as if you were viewing like alien cultural travel, like visiting this culture and that culture and this culture, and you could come to understand the space of all possible intelligences and like wildly different societies, etc. And so I think that there's a risk of not seeing that as much, or seeing it at all, if you start off with a human seed, because you're going to get something that looks a lot like human society and human culture. However, I think about the staging here. Like, in my opinion, let's create the first open-ended process that's really exciting, or the first few, and those can be based on human data, and they basically will be a narrow cone around human society, and they'll probably reflect a lot of our biases, and we'll figure out how this stuff works. And then eventually we'll get to the more super ambitious thing of seeing what wildly different societies look like. Because right now, I mean, take our RL results as kind of a microcosm of what we're trying to achieve. With pre-training, you could do pretty impressive stuff, and you could actually go and accomplish things like learning the diamond tools. Without that, flatline, you almost learn nothing, right? And so barring some major algorithmic innovations that will get us past that exploration bottleneck without using human data, like this is the only way to play the game. And so like getting even like a diamond pickaxe, while impressive for AI, is not that impressive for a human player if you want them to build computers and build Hogwarts and things like that. And so I think this is going to be a dramatic shortcut that's going to get us to where we want to get to a lot faster. But ultimately, I want to put this out there. I think scientifically, it is a fascinating challenge we should absolutely pursue, which is how do we do this without human data? Because we know the natural evolution did it, and we don't want these biases in the system, because ultimately we do want to see the entire space of intelligences and what in the possibilities. And so I'm okay with like kind of the impoverished version now, because it's the fastest way to play. But ultimately, we do want to do what you're saying, Sebastian.
I like the comparison that you might not. Sorry, I just wanted to say I like the comparison that you might, when you get a lot of, you could get like really intelligent, like human-like intelligence, but you might never get something like an octopus or something that solved intelligence in a very different way, because you took this shortcut. But I also agree that it's probably it's a very useful shortcut probably to take. Sorry.
No worries. Yeah. So just to add to what Jeff said, first of all, I completely agree. There is like an exploration bottleneck, and what VPT solved was like kind of getting familiar with all the motor skills. So the agent does not like randomly do things and then cannot even walk in a straight line, right? Like you need to be able to walk in a straight line and do some crafting to make anything interesting happen. So the exploration burden is very real, and I think it's important to use some human data to bootstrap. But the point I want to add is, I think Minecraft is a little bit special because this is a very human-centric game. Like in it, there are many concepts that we know from common sense. So let's say in Minecraft, you can use sand to craft a glass, and you can use water to put out lava. All of these are like common sense knowledge, and humans have curated like so much knowledge online about, so it's like both from the common knowledge, let's say on Wikipedia, or just on like general text corpus, and also on Minecraft specialized knowledge. So I feel that all of these knowledge can be combined to bootstrap the agent to a very good state, so that it can understand language and then do certain tasks that it is instructed to do. And after that, we can let the agent loose, right? We can set it loose in Minecraft, discover new things that humans have not even considered before. And also back to the problem with like collaborating with humans. language is another like great interface. So humans can even help the agent, just like we kind of mentor a child, right? Like we tell the child, okay, like these are some of the things you can think of, or how we tell grad students, right? Like as advisors, you tell grad students, okay, these are some promising ideas to explore, but exactly how you implement those ideas, it's up to you. But for advisors, we can point the AI to the right direction. So I think like Minecraft is quite special in this framework.
Mm-hmm. Yeah, I mean, like if you look at like a baby, it's like a cognitive development in early stage, like a lot of learning. They are not born in a vacuum, right? So they actually like imitate their parents and to learn a lot of skills. They learn to stick their tongue out like in a few days after born, like looking at their parents. So I think, I mean, if we have this human data, we should use it. That's my opinion. That allows us to do more structured exploration. Like, so a lot of this creative task requires really prolonged interaction with the environments, like 10,000 of steps. If we can sort of those like basic skills, we can level up the kind of level of the reasoning or exploration so that we can get to do more interesting data, discover more interesting goals. But I do think like, so only training on human data does not replace the agent's own experience. So like at the end of the day, we need to have a mechanism to for the agents to self-set their own goals and or like have their own intents or curiosity to explore the world. I think that touched upon like a kind of topics on like artificial curiosity and or like a curriculum learning, like what Jeff also said. So we have been also kind of developing along that line of work, like also following like Jeff's line of work on point on how to kind of have agents that self-create their own environment or kind of a procedurally generate their own tasks, right? So as a self-play as a problem generator and a problem solver at the same time, and we can cast that as some kind of adversarial learning framework. But I think more research have to be done here because like we have been only focused on very small domain, not really Minecraft scale. So, but it's interesting research direction to see how can we have the agent like self generation of goals and intents.
Yeah, I love one of the things that we had on our roadmap at OpenAI was something very similar to what you proposed in the MineDojo paper, which is using GPT with to not only generate tasks, but generate subtasks. And also then if you combine that with the curriculum paper that we did for Minecraft. So basically, if you went to GPT and you said, what are the first 10 things I should do in Minecraft? And if it could solve those, good. You say, okay, now I solve those, what's next? And if you couldn't solve them, you go back to GPT and you say, you challenged me to make an iron shovel, but I didn't know how to do that. Like, can you help me? And then maybe it breaks down the task and you assign those as subtasks. And if it solves those, great. If not, you ask for more help. And then you basically could just do that with a learning progress-based curriculum like we have in the earlier paper that I mentioned, and just kind of fan out and try to learn all of the skills that there are in Minecraft. And so kind of having a natural language conditioned agent that can parse and consume the kind of the tasks and then the subtasks from GPT, pair that with a learning progress based thing in an open-ended environment and a lot of compute, which you have at NVIDIA, and boom, you have a very powerful, exciting research project that I think would be really interesting to pursue and see somebody pursue in the next year. I'm glad to hear that you're maybe working on that now.
Yeah, even better if the GPT is fine-tuned or like even trained with the Reddit data that you already have expert knowledge on this game. So it's truly not just a general language model, but like a true expert on everything you can do with Minecraft.
Yeah, and then also you can seed that agent with the VPT agent, which already knows how to do a lot of stuff in the world. And so it's like off to the races. And I just saw that Thomas is on, Thomas McConey. Thomas did this amazing thread right after both papers came out in which he proposed something very similar, which is how the MineDojo work and the VPT work really dovetail nicely together. It'd be great to see them put together. So thanks for that thread, Thomas.
I had a quick question about the embodiment. Like, what do you think would change depending on the form factor of these agents, right? Because a lot of the intelligence and like the exploration that happens is conditioned by embodiment and relationship of the body to the environment in which you're placing these agents.
I'm sorry, I was actually, my internet hiccup there for a second. Was that a question for me?
Yes, yes.
Okay, can you say it again? I apologize.
Yeah, I was curious, like, because we talked a lot about the task, if it's open-ended or directed and so on, but and you were talking about discovering different types of intelligence, and I wonder, what do you think it's the role of embodiment, like the form factors that these agents have, like I'm thinking Philippe Oudier at INRIA in France had these robots of very different bodies, and like he would put them in an environment where they had to develop a language to speak with each other, and the type of languages that they would develop change depending on their form factor, right?
Yeah.
And that kind of like gets me to think of, you know, you talked about evolution and adaptation. A lot of that had to do between the relationship of our bodies and the environment we're in. So a lot of this learning and intelligence you will uncover is also determined by that adaptation of form factor body to environment in which you're creating that you're creating for these agents.
Yeah, those are wonderful questions. So I kind of have a similarly staged version of this answer. I think that kind of like, you know, you think about like the 80%, the 80-20 rule, the 90-10 rule, you kind of get like most of the interesting stuff and then the long tail of stuff that's harder and fascinating. So I think there's probably like a core to intelligence that probably is relatively independent of the body. For example, thinking about like, you know, symbolic thought, learning how to play chess, do math, things like that. You probably, or, you know, you probably could do that almost no matter what your body was. But there are subtleties, like you mentioned, like how you might end up communicating and what that would do to influence the way that you think about the world. So there's this wonderful book called Star Maker and First and Last Men. It's this great science fiction book, and they travel to all these different planets. And one of my favorite parts of the book is they visit a planet that had like a really thick cloud of dust. So you couldn't really see on the planet. It was just dark all the time. But the creatures then basically became very dominant in smell. And if you think about it, like a lot of our metaphors for understanding are vision-based. Like, oh, I see, you know, like that's clear to me. There's like this huge extension of vision-based metaphors we have for understanding. Whereas in this book, all of those were just transformed into touch and smell. It'd be like, oh yeah, that smells really good. Or like, oh yeah, like, you know, I'm picking up the scent of what you're saying, or et cetera, et cetera. And so like subtle things about that in terms of how they think and express in their metaphors might really depend on the embodiment. Do they have, like, if they communicate via like vibrating their hands, they probably have an entirely different set of metaphors for like what happens when I like finally understand you, et cetera. But I mean, to some extent, that's very interesting and fascinating. Like once we're at the point of understanding and appreciating those subtleties, I think we're way down the path towards understanding the space of possible intelligences. But there's so much between here and there just to get that 80% before we enjoy that last 20% that I'm not that worried about the particular embodiment. Like I think you could study AGI in maybe even just a text-based, a purely text-based thing. I think it's one of the most fascinating things. Like, could GPT, just by studying the internet and never being in a 3D world, how close could it get to like human level intelligence and understanding us? Or would it completely have no 3D common sense? You know, even if it read about it forever, but it's never walked around in a 3D world, so it doesn't understand the idea of like occlusion and like a shortcut. That's a fascinating thing to think about. And so I think this is one of the cool things about doing AI research is that these become testable hypotheses because we'll find out. My instincts are that the body doesn't matter as much as maybe like Rolf Pfeiffer or Josh Barngard have advocated over the years. But, you know, Josh and I debate this over beers. So we'll find out.
So if we are moving to like multimodal learning, I feel that embodiment could help kind of ground some of like the language concepts, the linguistic concepts in the visual world or in the physics world. So I guess, yeah, it depends on kind of what's the downstream application you're aiming for. So if it's, you know, video games or like robotics, then embodiment may be very useful because you are receiving, the agent is receiving information from multimodal sensors, and you need to do this kind of multimodal concept grounding. And again, I think language is a very good medium for doing that. Just like Clip from OpenAI, all of these, and also DALL-E from OpenAI, right? Like this multimodal connection is becoming a very hot research topic. But I guess, you know, if we want to kind of create completely like open-ended agent or like AI generating algorithms, I feel that embodiment, it could be embodiment agnostic. Like this is a general paradigm that can be applied to all embodiments. So yeah, I think these are all great points from Jeff.
I fully agree, and that's what another reason I just want to trumpet the genius of the natural language conditioned agents and pre-training of the MineDojo vision of the paper. It's just so right. Go back to my example of like go pick up all the blue things. Well, imagine instead if it was go pick up all the chess pieces. Well, if you don't know what a chess piece is and you have to learn that while also learning what the task is, it's just like, you know, it becomes combinatorially impossible or virtually impossible. But if you come to the world knowing what a chess piece is, then you're so far ahead of the game. And so you can get that by, like, we were actually working on the same thing, just taking the transcripts of YouTube, like while people are talking about what they're doing, just like putting that in the conditioning to say like, what action should be taken or your contrastive learning or whatever. And then you learn, like what a diamond is and what a shovel is and what a tree is and what a cow is and a sheep is. You can get that all via pre-training. And then you're so like the learning task becomes so much easier. And you get over this, you just like have this giant shortcut to all the things you want to accomplish.
We are almost time, or actually time, but maybe we can do a little bit of Q&A from the audience that's been with us for this hour.
There are some questions in chat that I haven't been able to read at the same time as participating in the discussion. I don't know if anybody wants to speak up. Thomas, did you have one, or are you just commenting? I'm calling you out. No question. Thanks, Thomas.
Anyone has a question that you want to speak up or type?
Yeah, so Thomas is basically echoing kind of the idea of using a poet style thing with text-based goals provided by GPT and taking advantage of GPT's knowledge of Minecraft, which it got from pre-training. It would be even better if fine-tuned to propose like, oh, you know how to do that? This is what's next, or this is what's next, or this is what's next. And, I think that is just like, just such an awesome project to be pushing on.
We're actually very surprised that GPT-3 just out of box, the DaVinci model already knows a lot about Minecraft.
Yeah, I mean, it's such a popular game, as you mentioned.
Yes,
like, how could
exactly.
How could it not? Everybody, there's so much text on the internet about it. Yeah, we did the same thing. I did basically like, how do you do this in Minecraft? What are the first 10 things to learn in Minecraft? And, like at least half of them are very good suggestions. So you can see it already could basically be used to generate a curriculum.
Yes.
We have a raised hand from Hamid. Do you want to?
Hey, can you hear me?
Mm-hmm.
All right, great. Thanks for the talk. I just wanted to know your opinion on if we were to build an agent that can interact with the environment, and we wanted to use the intuition and common sense reasoning of a language model, but the perception kind of has a different input modality or a combination of different input modalities. What are the important aspects to take into account mapping an unseen input representation to the domain of the language model? Because there are like different paradigms at the moment on mapping kind of a sequence of inputs from perception to the domain of language model. What are your thoughts in that direction?
My personal thoughts, I'll jump in because nobody else was, is I really like the idea of universal inputs and outputs. So you basically like a computer screen. Like right now, all of us are looking at a bunch of pixels, and we have, keyboard, mouse, and I guess I'm using a microphone as well. You set that basic environment up, and as long as we aren't talking about robotics and like, stuff in the real world, but in the computer world, which is already a massive amount of learning tasks, you've got this universal API, and then you never have to deal with a new modality in some sense at inference time, because, you might be dealing with a different modality in the sense that like you've never heard rock music before, and all of a sudden that's coming out of the speakers. I guess speakers is another one. And you might see a picture of text as opposed to like getting the characters of the text. But if you basically just go from the same kind of inputs and outputs we have on a computer, think of all the things you can do on a computer. It's very, very universal. So I like that as a starting place for agents.
Right. So what you're suggesting is to have like a universal representation of all inputs rather than mapping a certain input to another modality.
That's exactly right. Yeah, I tend to really like the long-term view of AI, where I'm not trying to solve like one particular problem with one particular modality. I want to get like the very general long-term solutions in place, and then like start to like create a path towards that future.
I like that, but one kind of blockage is that the large models, pre-trained models, are usually trained on different kinds of models. For example, we have language models trained on text, and then we have large, I don't know, video models trained on images or sequence of images. And if we were to kind of use those and leverage those, it introduces this challenge of mapping between different kind of modalities, or just make a decision that, okay, text is going to be my universal representation of all things. I'm just mapping everything to text or some language model tokens, and then I take it from there. In the
or we should fix the problem you mentioned and not have foundation models be domain specific. Let's just start training the general domain models that can take all the, settle on a set of core modalities, which is like pixels, sound, and then the outputs are like keyboard, mouse, and sound, and then boom, start training foundation models on those. Or you can do what the MineDojo team did, and many people have done, which is like, all right, I'm going to take my vision piece, I'm going to take my GPT piece, and I'm going to like run them through, and then I'm just going to like merge them. But I'd prefer to go to a domain. I really think the future is going to be models that can consume like all of these modalities, and we don't have like separate models for separate domains.
Right.
I completely agree with Jeff. Oh. Yeah, sorry, I just want to quickly bring up. So I completely agree with Jeff. And there are actually a couple of like great works coming out from the community. Like from DeepMind, there's the perceiver model that can process all kinds of different modalities. And yeah, multimodal fusion is a very hot topic. So I agree with Jeff. This is the kind of the way for the future.
Thank you.
Maybe I'll highlight one question from the chat. That's interesting to me. Are there some examples of real world applications of these methods learned from Minecraft setting?
So I don't know anything about like in the actual real world, but I just, one thing I wanted to mention is like that it actually is so it's great having these systems run in Minecraft, and what's really what we're trying to do now with this company Model AI is actually using them for one thing that they're really good at is finding bugs in games. Like if you have a system and that can play a game really well, like we want to train large foundation models on not just Minecraft, but like a variety of different games, then you can actually use them in addition to human testers. You can just have them play the game, and they can try to, you can instruct them to find bugs in the game, and then they would report those bugs back to you. So I think that's an interesting application that is not just we're trying to generate more general agents, but we can actually use it for tasks where before we needed a lot of hundreds of human testers that had to do this repetitive task. Now we can use AI agents that play these games, and then they can report back here, I found this bug, I found this glitch, this thing is not working, which I think is a nice combination of open-ended search methods and these kind of pre-trained large-scale foundation models.
Yeah, I bet Go Explorer is going to be really good about finding bugs in games. It found a lot in Atari.
Yeah,
to directly answer your question,
reward hacking.
Oh yeah, reward hacking in general, RL optimization. Yeah. I'm not yet familiar with anybody using this in the real world on our end. I don't know about you guys, UK and Jim.
So part of it is like debugging the games and finding the defects, as you guys said, but also like just improving general the gamers' experience by making the non-playable characters, so-called NPC, more interesting, right? So if you play Pokemon or like other type of RPG games before, and you know that if you walk to a character and you talk to him, it speak one thing, and then you come back another day and to talk to the same person, it speaks exactly the same thing, right? So how can you kind of really personalize and kind of make this non-playable characters adaptive, so that like kind of it makes significantly improve the like a gamer's experience. Like it feels like now that kind of in this game is unique to its own experience as it plays. The game also adapt to his or her own preferences and kind of personality, right? So this is something that I think within the game, of course, beyond the game, we talk about the general use computers and using the keyboard mouse interface, or even like, so some of the principles I think like through building general purpose agents in Minecraft, I think can transfer to more practical domains like robotics as like something that I personally care about. Like, so, right. So we care about like more eventually move beyond Minecraft and to the real world settings, like how those can provide guidelines for building machine learning foundation for embodied agents or even kind of physical robotic systems as well.
Yeah, one of the things we want to do, we're hopeful that our paper will get into NeurIPS. We don't know yet, but if it does, what we're planning on doing for the celebration party is trying to create a game server for our team where we put in a bunch of VPT agents alongside the humans, and we get to like all play together, because we've always wanted to do that. We haven't done it yet, but you can't yet talk to our agent because we didn't get to the text conditional piece yet. We were hoping to. So it'd be fun also if you had a text conditional like Minecraft pet that you could like play with and like be like, go get me some redstone, I'm building something, and it like comes back with redstone or whatever. It'd be fun.
Yeah, I love that because like I'm not a game player, but I kind of want to get into it. But I'm also lazy. So like I have some idea I want to design. I want to click all the things. Can I just talk to an agent and he does half of the work for me, and then I like fine tune or I advise the agent. It's like a
There you
collaborative.
go. Text conditional AI assistance.
Roseanne can be our first customer, first beta
There you
tester. If Roseanne's happy, then we're doing a great job.
That's true. That's our objective function. Make Roseanne
Yes.
happy. We've solved the alignment problem.
Absolutely.
Make me happy with a game. That's actually a pretty hard challenge. I don't play games. I'm usually unsatisfied with games.
Challenge accepted. Yeah.
Cool. I think that's probably it. We're already 10 minutes over time. Thanks everyone for showing up and having this lovely panel at DLCT.
Thank you, Roseanne.
Thanks a lot for the invite.
Thank you so much. Yeah, thanks everyone, Jeff and Sebastian. Yeah, great discussion.
Great
Thanks a lot.
paper.
Thank you,
I
guys.
loved it. I
Thank you
loved
all.
reading it. Congratulations.
Same, PPT, awesome. Yeah, thanks a lot.
Okay. Thanks, everyone. Bye-bye.
Okay.
Bye.
Weekend. Bye.